In this video, we'll go over answers for our Wednesday, March 25th problem set. Alright, so the theme of these problems are weak acids. So for Monday's problem set and Monday's content, we were talking about strong acids. Strong acids dissociate 100%. So if you have 1 molar strong acid, you'll make 1 molar of H plus or H3O plus. Weak acids do not. They will dissociate, break down in a smaller percentage. And so we need to go back to the ice table and equilibrium to understand how much they break down by. So let's take a look at this. So we have a sample of hydrofluoric acid. So determine the pH of an HF solution at the following concentrations. I'm showing you one. If Ka for HF is 6.8 times 10 to the minus 4. Alright, so anytime we deal with a weak acid, and you will know if it's a weak acid if it has a Ka value. If it's a strong acid, it usually doesn't have this Ka value. But so we have weak acid, HF goes to H plus F minus. So that's my equation. And we write our Ka expression. Now, Ka is just like our KEQs. The A is acid. So it's products over reactants. Remember, if we have any stoichiometry, we'll raise that to that power. We don't have any here, they're all 1. So it's H, concentration of H times F divided by HF. Alright, so we start with 0.250 molar of HF. So that's our initial 0 of hydrogen, 0 of fluorine. And just like we talked about previously when we were last visiting ice tables, if we have only reactants and no products, we lose reactant and we gain products. In this E column is our ledger. So 0.250 minus X, so that's E, then X and X. Now, we could use the quadratic equation to solve this, but if we look at our Ka and our initial concentration is 100 times bigger than our Ka. Therefore, we can assume that the minus X here in 0.250 minus X is so small that it's not going to change our answer significantly if we just ignore it. And remember, if X is being multiplied or divided by something, we can't ignore it no matter how small it is, so we can't ignore these two X's. Right, so we have this E column. Let's plug it in to our Ka expression. So 6.8 times 10 to the minus 4 is our Ka. Then H and F minus are X times X, which is X squared, divided by concentration of HF, which is 0.250. Multiply each side by 0.250, square root each side to solve for X. X equals 0.0130. That's our concentration of H plus. That's how much HF broke down, 0.0130. But we want the pH of the solution. pH equals minus log H plus. So it equals minus log concentration of H plus, which is 0.0130. When you plug that in your calculator, you actually type negative log concentration. You should get a pH of 1.89. Alright, question 2. It's similar, but a little bit different here. So we have a 0.185 molar solution of a generic weak acid, HA. So that A could stand for more or less any element. This has a pH of 2.98. This time, we're solving for Ka. So we can start the same way that we did the last problem. We can do the ice table. HA goes to H plus plus A minus. We start with 0.850. 0, only reactants, so minus X, 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 then 0.185 minus X, X, and X. Now, I'm going to assume X is small, But we can actually do that calculation because we're given the pH. We actually know what these x's are. So pH equals 2.98. Well, pH is minus log H plus equals 2.98. Multiply each side by a negative. Log of H plus equals negative 2.98. Now, when we're taking the log of a variable, I cannot touch that variable until I get rid of this log. The way to get rid of a log is you raise each side to the power of 10. So 10 to the power of something that's a log, they cancel out and you're just left with your variable. So H plus equals 10 to the power of negative 2.98. H plus equals 0.00105. You can see this number, this 0.00105, is much smaller than 0.185. So my assumption that this minus x was true. However, we do have x, so if you actually wanted to do that subtraction, you can. You would get, what, 0.184? Yeah, 0.184, so not that big of a difference. All right, let's figure out our Ka. So we need to write the general expression for Ka. Ka equals H plus multiplied by A minus divided by HA. So we plug in our equilibrium concentrations, 0.00105 times 0.00105 divided by 0.185. Our Ka equals 5.96 times 10 to the minus 6. And that will bring us to question 3. Question 3, we're looking at percent ionization now, which is the concentration of our ionized acid divided by our initial concentration of acid. So if we're given a solution of 0.100 molar, find the pH and percent ionization of this weak monoprotic acid. All right, and Ka is 1.0 times 10 to the minus 5. So we start with our generic equation. HA goes to H plus A minus 0.10000. Sorry, that was a little confusing. HA is 0.100. H plus is 0. A minus is 0. Start with only reactants, so we subtract x. Then we have product, so it's XX. 0.1 minus x. X and X for H and A minus. Set up our Ka expression. Products over reactants. H plus multiplied by A minus divided by HA equals Ka, which is 1.0 times 10 to the minus 5. All right. Now, I'm gonna, if I look at my starting concentration of 0.1, it is 100 times bigger than Ka, so I can ignore that X. Nope. That might not be the case for B and C, so make sure you check what the Ka is. You can't always ignore that X. You have to make sure, okay, is my starting concentration roughly 100 times bigger than my Ka? If so, ignore X. But here it is, so I can ignore this X. I can safely assume it's going to be small. So 1.0 times 10 to the minus 5 equals X times X divided by 0.1. Multiply each side by 0.1, which is 1.0 times 10 to the minus 6 equals x squared. X equals 0.001. So I forgot to solve for pH on this, but it's just like we did previously. pH is minus log H plus. We just found what H plus is, 0.001. So we want to do minus log 0.001. Now we want to do percent ionization. To do percent ionization, you do the concentration of your ionized acid. So the amount that broke down, that's what it means by ionize. How much of it broke down? Well, 0.001 broke down. What was your initial concentration? 0.1. So 0.001 divided by 0.1 times 100% is 1% of your acid broke down. So very weak acid. Only 1 out of 100 molecules of HA will break down to a H plus and A minus. That's what that 1% means. And that ends this video. As always, if you are not understanding the material, if you have trouble how the system is working for you, please email me. and we can set up something. I know online classes like this are difficult. Please don't despair. I am here to help you however I can. However, I do need to hear from you if you would like assistance in some way. So please do not hesitate to reach out to me. Otherwise, I will see you in the next video.